Water treatment is often a hidden hero in our daily lives, quietly working behind the scenes to ensure that the water we use is clean, safe, and always available when we need it. At the very heart of this complex process are pumps, powerful machines that keep everything moving. Without pumps, water simply wouldn't travel from rivers, lakes, or reservoirs to the treatment facilities, and ultimately to your faucet at home. These pumps are the unsung workhorses of the water world, tirelessly preventing stagnation and ensuring a continuous flow. When a pump fails, it's not just a minor inconvenience. It can quickly escalate into a crisis that affects entire communities, disrupting daily life and putting public health at risk. That's why installing and maintaining pumps correctly is a huge responsibility. It's not just another technical task. It's a commitment to the well-being of everyone who relies on clean water. Every step, from installation to regular testing, is about protecting public health and ensuring safety for all. Without pumps, even the most advanced water treatment plant is just a collection of empty tanks and idle equipment, unable to serve its purpose. Pumps are the driving force that transforms dirty, contaminated water into the clean, drinkable water that sustains our lives. So, the next time you turn on your tap and see clear water flowing, take a moment to appreciate the vital role pumps play in making that possible. They truly are the backbone of modern water treatment. At a water treatment plant, pumps are the unsung heroes working behind the scenes. They keep water moving, clean, and safe for communities. Whether you're new to the field or a seasoned pro, you'll quickly realize just how essential these machines are to daily operations. On the job, you'll encounter several key pump types, each with its own strengths and quirks. Understanding these differences is crucial for keeping everything running smoothly. Centrifugal pumps are like water slingshots, spinning water with force and reliability. They're everywhere in the plant, handling large volumes with ease and making them the backbone of most water movement tasks. Submersible pumps, on the other hand, live underwater. They're designed to operate while fully submerged, making them perfect for deep wells, sumps, and places where other pumps just can't reach. Positive displacement pumps are all about precision. They're ideal for dosing chemicals or moving thick, viscous fluids. When accuracy matters, these pumps deliver the exact amount needed every time. Vertical turbine pumps combine surface power with deep reach. They're often used to draw water from deep underground sources, using a series of stacked impellers to lift water efficiently to the surface. Each pump type has its own quirks and specific rules for installation. Proper alignment, secure mounting, and correct connections are all vital to ensure long-term performance and safety. Respect the hardware, and it'll respect you back. Regular inspections, maintenance, and following manufacturer guidelines can prevent costly breakdowns and keep the plant running smoothly. Knowing your pump, how it works, what it needs, and how to troubleshoot issues is the first step to success in water treatment operations. Each type of pump plays a unique role in the water treatment symphony, working together to move, clean, and distribute water efficiently throughout the facility. Understanding how these pumps interact and monitoring their performance ensures a smooth, reliable operation day after day. So, choose your pumps wisely, maintain them well, and you'll ensure both efficiency and reliability for your entire water treatment system. Before installing a pump, it's essential to thoroughly inspect the foundation. The foundation is the backbone of the entire installation, supporting not just the pump, but also the motor and all connected systems. Any flaws at this stage can lead to problems down the line, so take your time to ensure everything is in order. A solid, level base is absolutely crucial. It prevents vibration damage, which can shorten the lifespan of your equipment and lead to costly repairs. Use precision tools to check for flatness and stability, making sure the surface is perfectly even before moving forward. Precision in setting anchor bolts is key. These bolts will hold the pump and motor securely in place, so their placement must be exact. Double-check measurements and alignment before the concrete sets, as adjustments later will be difficult and expensive. Once the concrete has fully cured and reached its required strength, it's time to carefully bring in the pump and motor. Use cranes or other lifting equipment to avoid any damage during transport and placement. Make sure the equipment is gently lowered onto the base to prevent misalignment. Alignment is absolutely critical at this stage. Even a slight misalignment between the pump and motor shafts can cause excessive wear, vibration, and even catastrophic failure over time. Take the time to check and recheck alignment before proceeding. Use advanced tools like laser alignment systems or digital dial indicators for the highest accuracy. These tools help you achieve precise alignment, reducing the risk of future issues and ensuring smooth, efficient operation. When connecting pipes, do so with care and attention. The pipes should meet the pump naturally, without any force or strain. Proper pipe alignment prevents stress on the pump casing and helps maintain system integrity. Avoid forcing pipes into position, as this can introduce unwanted stress and lead to leaks or cracks in the pump casing. Take the time to adjust and fit each connection perfectly. Finally, connect the electrical and instrumentation systems. Ensure all wiring is secure, properly labeled, and meets safety standards. Double-check connections to avoid electrical faults or malfunctions. Every connection, whether mechanical or electrical, must be perfect for smooth and reliable operation. Inspect each joint, bolt, and wire to confirm everything is tight and correctly installed. A well-installed pump is the foundation of long-term reliability and efficiency. With careful attention to every detail, you ensure the system will run smoothly for years to come, minimizing downtime and maximizing performance. Before starting, prime the pump with water. Running dry can cause severe damage. Check for air release to ensure it's fully primed. The trial run checks rotation direction. Adjust if needed. Start with the discharge valve partially closed. Listen for unusual noises and check pressure gauges. The performance test ensures the pump meets specifications. Compare real-world data to the performance curve. Only after passing can the system be handed over. It's the culmination of all your hard work. Rushing the foundation is a costly mistake. Impatience can lead to cracks and misalignment. Be patient. Follow curing instructions precisely. Never use the pump to force misaligned pipes. Proper support and alignment prevent pipe strain. Misalignment causes destructive vibrations. Use laser alignment tools and recheck after running. Don't overlook lubrication. It's crucial for longevity. A checklist ensures all steps are completed correctly. Avoiding these blunders ensures a reliable installation. As a new engineer, listen to experienced workers. Their hands-on knowledge is invaluable. Get involved. Develop a physical intuition for the equipment. Trust, but verify. Double-check everything. Ensure the installation meets design specifications. A successful installation is the foundation for reliability. Your work today affects future operations. Take pride in doing it right. It's a meaningful responsibility. You're building infrastructure that keeps communities safe. It's a job worth doing well.